Okay, so in this lecture we're going to talk about the previous video. So this is going to be based off of video 5B. And what we have is we have our equations. Work equals force times distance. We have kinetic energy equals 1/2 mv squared, mass times velocity squared, and we have gravitational potential energy is equal to mass times gravity times height. Okay, so we have force, distance, mass, velocity, gravity, and height. And we know that our force from the previous lecture was 2.75 newtons. That was the force to bring it up the incline. My distance was 1.26 meters. My mass was 2.31 kilograms. My velocity, I don't know what my velocity is yet, so we're going to have to get there. That's going to be the first thing we're going to do. My gravity is negative 9.81 meters per second squared, and my height is going to be 0.14 meters. Okay, so let's fill in this velocity here. Now, to fill in the velocity, we're going to have to go to one of our older charts. We're going to have xt, vi, vf, a, and we're going to say that we know that the x that it traveled was the 1.26 meters down the incline. The time that it took was 1.5 seconds. Its initial velocity was 0 meter per second. The final velocity is what we're looking for, and we don't care about the acceleration. Okay, so what we can do is we can use x equals vf plus vi divided by 2 times t. We can rearrange that so that we're going to have 2x divided by t is equal to vf plus vi, and so vf is going to be 2x divided by t minus vi. So vf is going to be 2 times 1.26 meters divided by 1.5 seconds minus 0. So 2 times 1.26 meters divided by 1.5 seconds gives me 1.68 meters per second. Okay, so let's start plugging these values into these equations and see what happens. Let's do work equals force times distance. And so I'm going to say my work is going to be 2.75 newtons times 1.26 meters. And so I'm going to say that the work that I did is 3.465, so I'm going to call that 3.5. What are the units? Take a second. What are the units? They are joules. 3.5 joules. Okay, so then from the top of the incline, I let it roll down, and so I had my kinetic energy is at the very bottom was 1/2 of 2.31 kilograms times 1.68 meters per second, and remember to square that. Please always remember to square when you do the calculations. So I'm going to come up with, I'm going to do 0.5 times 2.31 times 1.68 squared, and I'm going to come up with 3.26. So I'm going to call it 3.3 joules. Okay, and then the last thing I'm going to do, so that's a little box right there, that's a little box right there, and then I'm going to finally say GPE is mgh, so GPE is my mass was 2.31 kilograms. My acceleration due to gravity was negative 9.81 meters per second squared, and my height was 0.14 meters. Okay. And I plug that in. I go 2.31 times negative 9.81 times 0.14, and I get negative, I'm going to round that again, I'm going to say negative 3.2 joules. Okay. Now, if I was living in a perfect world, if I was a usual physics teacher, I would probably just make up numbers so that every single thing just kind of all adds up all together. But what we're going to find is that these numbers are similar, but they don't completely all add up. So what we have is the following situation. I took my cart and I dragged it up the incline and I gave it 3.5 joules of work. When it was at the top of the incline, it had 3.2 joules of potential energy, and then when I let it go down the incline, it gave up that 3.2 joules of potential energy, and at the very bottom, all that potential energy was converted into kinetic energy, and so we ended up with 3.3 joules, which is pretty close to 3.2 of kinetic energy down at the bottom. So that's how they're all interrelated. Work turns into potential energy, turns into kinetic energy.